Zoom recording for all the people who are not here so they can hear what we talked about. So I will now share to you a different screen, kind of what we're talking about this week, so that you can get a basic, brief summary of it, but then there's different videos and readings for you to do so you can kind of explore these topics on your own and give some thoughts about it through the week. So here we go. All right, so like I said earlier, there's still a document you submit on, but it's not the same kind of format with the field journal and the labs. This week is different, and it will look different kind of content. So still learning some about the Earth, but we're going to look at the internal structure, fossils, and some about the age of the Earth and how people estimate that. So it's kind of a lot to fit into 3 days, so I don't expect you to understand all of these topics fully, but I do expect you to just know the basics of them and then to think about kind of the concepts around them, like how accurate are these estimates of the age of the Earth, and why do we need to have evidence, and why are explanations important? How do scientists work, and things like that. So those are the more general ideas that I want you to focus on, and to just know some about these concepts will be helpful for you to think about those things. So today you can just look through those last sections in your course book, because those will help give you the basic context for what we're talking about. And then you're going to do a small part of this document here. So 2 things. You'll read this document. There's some videos in there. If there's a link, make sure you click on it and watch it. And then do the responses. So that's number 1. And then number 2, on Wednesday, I just want you to record yourself 2 to 3 minutes responding, and that's total, responding to these 2 things. And if you find them confusing a little bit right now, that's okay. I'm going to come back to them after we've talked about the document, so maybe they'll make more sense. So if I scroll down here, again, there's 3 parts to this. You'll do 1 today, 1 tomorrow, 1 Wednesday, and then you're just going to make a short response. And so post it on YouTube and put the link here so that I can see you responding to these 2 things. So today, part 1, you're talking about fossils in the fossil record. So basically, we can see things, they're recorded, how they looked in the past, based on a fossil. So a fossil is just something that's buried really quickly, and its remains are replaced with minerals. So in order for that to happen, it needs to be buried really quickly, because if it's not, something might decompose it. Like if something is just sitting out in the open, you know, it's gonna break down because of the air and bugs and all these things. But if it's buried really quickly in there's sediments, it can be trapped into there so it doesn't decompose. It also needs to be something kind of hard, so that's why you'll see fossils that are like the bones of an animal, not like all of the organs and skin and things like that. They kind of they don't get replaced by the minerals like the bones do. So when I say they're replaced with minerals, that means all the sediments come on top, but then there's also the water. It will come in with different minerals, and so the small minerals will kind of go in and they'll replace whatever was there in the bone. So when you find a fossil, it's not the actual bone, it's just in the shape of the bone that's been replaced with these minerals, as this was changing into a rock. So yeah, it needs to happen pretty quickly. At least be trapped from all of the elements, water, air, chemicals, things like that. So a couple of videos for you to see that process visually, and then answer this question. And then, so yeah, this is what a fossil would look like if you found it just like this animal was laid down pretty quickly. But if you think about how fossils are made, remember, buried really quickly, what kind of conditions would exist for that to happen? A lot of times it's very catastrophic, maybe a volcano spewing or maybe a landslide that buries a lot of things. So often we don't find them all with the bones right next to each other, which is really cool, but a lot of times we would find them like this in a fossil graveyard, right? Expectations versus reality. And sometimes we do find it like that, and that's awesome. You could know that this fits there and this fits there. But when we find it like this, sometimes we have to make guesses about what goes where and what goes with what, and often there can be mistakes made. So, we have to be careful when making guesses about these kind of creatures. Whereas this one, there are certain things we can know, like what kind of jaw, teeth does it have that tells us what it eats, how are its hips aligned that tells us, does it walk on all four legs, does it stand up? So we can know certain things from the fossils, but we can't know everything. We don't know what color it was. We don't know how old it was when it died. Maybe generally we know if it was a baby or an older one, but we can't know the exact age. So there's a lot that we have to guess, but there's also a lot we can learn. So that's what you're doing today. You're just answering those two questions after you watch those two videos. All right, tomorrow you will talk about Earth's history. So this one's a little bit longer, but we don't have a Zoom session tomorrow besides the Q&A, so you'll have more time to think about it. And tomorrow you'll think about Earth's history. So how do we know what happened in the past of the Earth? We know what the Bible tells us, right? And we can also get clues from the geologic column. So you can look at rocks deep down in the Earth's surface and you can see certain things of what might have happened for them to form, right? These are clues, these are evidence. So,
Miss, we only need to join the Q&A if we have questions, right?
Yep, that's right. So that's why you have more time to do this, because you don't have to join the Q&A. But definitely come if you do have questions. All right, so this is about dating, not dating like, finding a boyfriend or girlfriend, dating like figuring out the date that it was made, how old it is. So if you look down at these rock layers, they're sedimentary rocks. The youngest one will be on the top and the oldest one will be on the bottom, because obviously this one was laid down and then that one. So if you look at this kind of cartoon version here, this pink layer is a lot older than this blue layer up here, right? So that is actually called relative dating, because you can't see like exactly how old this pink one is, but you do know that it's older than that one, right? And it's pretty accurate. Like we can see, okay, there's not really many ways that this could be younger than that one, right? Absolute dating is finding the age in years, and it's not as accurate, right? So this would be like if I said, for example, Mark, I know that your mom is older than you. That would be relative dating. That's pretty accurate, right? If I were to say that your mom is older than you, I could be pretty sure that that's true. But if I were to try to tell you exactly how old your mother were, I would probably get it wrong, right? Maybe I could make a rough guess, but I might not want to do that. So yes, that's the difference. Relative, which one's older or younger. Absolute is saying an exact date. So you look at this rock and you say that is so and so and so years old, right? So that's the difference, relative and absolute. So if you look at this rock, you guys just answer this question: how can you tell which of these layers are older than others? What are some things you think happened here? So obviously there's sedimentary layers that got moved at some point. This was maybe some kind of igneous rock that peaked up through there. This one says basaltic rocks, so that's a type of basalt, which is an igneous rock. So there would have had to be some kind of magma that came up through those sedimentary layers. So if it comes up through the layers, it would be newer than the sedimentary rock, right? So this basalt would actually be newer than any of these other layers. Yeah. Okay. So that's relative dating, right? But absolute dating, we can't really check it, right? There's many methods, like someone mentioned in the chat, carbon dating, radioactive carbon, right? You can see how fast it decays, and there's methods to see the ratio of that versus the ones after they've been decayed. Yeah, so we can try to use that, but we can't go back and check it. unless we know how old the rock is. So some people have taken some rocks that they know the age of. So for example, from this one in Sicily or Mount St. Helens, like we know when these volcanoes erupted and when this igneous rock was formed, right? So if we know that, we know the actual age. So they knew the age, but they sent them to be tested. Someone who did not know the age using radiometric dating. This one is, there's many kinds. This one is potassium argon radiometric. And this is how old they found it to be. So for example, Mount St. Helens erupted in 1986. They said it could be up to 2.8 million years old. This one in Hawaii that was in 1800, they said 1.32 to 1.76 million years old. Or this one in Hawaii, 1959, 1.7 to 15.3 million. So even that is like 14 million years range, like that's huge. So when you look at this absolute dating, you know, it's right to be a little skeptical because we just don't know, right? If you try to prove this, it doesn't exactly work out. That doesn't mean that it's all incorrect. That just means that from what we've seen, it's not that accurate, right? It's hard to know how things started, all the conditions. Here's another with Mount St. Helens. They took different pieces of rock from the same time, the same eruption, and they were all dated at different millions of years old. So again, not super accurate. Okay, and then I have this basics for you on radiocarbon dating, which is one kind of radiometric dating. So you might not understand every technical detail, and again, that's not super important, but what's important is you understand the basic concepts that you know, you're using this radioactive element to basically see how old something is. So read through that, try to understand as much of it as you can. Just do your best. And then another video for you, write a response. So you'll kind of see two different views here this week of how some people say that the earth was kind of formed, all the things you see, the rocks you see were all formed very slowly, processes over billions of years. Another viewpoint is that it's catastrophic. So a lot of things happen very quickly, maybe not everything. And some evidence for this is a lot of our fossil record. So there's something called the Cambrian explosion where, so at a certain point here, okay, there's this line here, we call it the Cambrian explosion, because before that, it was older, there were not many fossils under here at all. And then all of a sudden, you see a bunch of fossils. So when we talk about fossils being laid down, remember how we said that they need to be buried very quickly? Well, that could have happened in a big event like the flood. Again, we weren't there to know these things, so we only have evidence from the earth and from what the Bible tells us. So the Bible tells us there was a flood, right? And so if we put that together with what we see, it makes a lot of sense that it would be here. And that a lot of the rocks would have changed positions, and there would be a lot of breaking up of the rock here if a giant flood were to have happened, right? So a lot of these layers could have happened very, very quickly, right? It doesn't have to be slow. Another example of something that happened very quickly, as far as formation of some kind of landform, is Krakatoa. So back in 1883, this is what it looked like before it exploded, and then after the eruption. And then less than 100 years later, it looked, so even like 50 years later-ish, it looked like this again. Stuff started to go back. It was green, and you could see a little Enoch Krakatoa growing in there. Oops, I think I have closer pictures. Up until when I went, and this was a lot taller back in 2017, right? And then it exploded again, and then kind of got smaller again. But you could see that a lot of this completely different like land transformation happens super quickly, not over billions of years. So yeah, we just have to go based on what we see, but it's important to look at evidence, right? Could have happened slowly based on what we see, like the erosion and things like that, and some could have also happened quickly. So those are some ideas you'll think about. And mainly geologists will divide the Earth's history into these huge chunks of time called eras. So you have the Paleozoic era, the Mesozoic, and the Cenozoic. And then each of these eras might be divided into smaller ones called periods. And you can read those here. I'm not going to read them all for you. Don't have to memorize them, but those are there for you to see. So this is the Cambrian one. So we're talking about the Cambrian explosion. That's when that happened. So why do we need to know this? So again, if God is telling something to us through his creation, right, it's important to look at it, to look at the evidence in that, to look at some of the clues and to decide what we think that means. And so I think that's a good reason to study geology, right? Okay, I see lots of things in the chat. I'll read those in a minute. You guys can see my screen, right? Hopefully. Okay. Can anyone not see my screen? Okay, that's good. Thanks, Troy. Just making sure I wasn't reading all this and you couldn't see it. All right, so then a couple more videos for you to watch. And then the last day should be a short day again because you're recording a video. Just taking notes of the few important concepts there. This is the structure of the Earth, the core, the mantle, the crust. And as you'll see, people haven't always thought the same way, right? Sometimes beliefs kind of changed over time, but you know, we've learned a lot about what the Earth is like now, and that helps us to know what it was like in the past. So some things to think about here. Again, just read through them. You don't have to understand them fully, even in order to give kind of a response about what you think about this. And normally I would cover this part in more time, so that's why I'm okay if you don't understand every single detail, but to start to think about it, and next year we'll talk about it more when we talk about evolution and looking at the age of the Earth and things like that. So be prepared to talk about this a little bit more next year. So just kind of get the general idea and general picture by reading through some of these things that I just talked about, watching those videos, taking some responses. Hopefully that's not too difficult for you. Again, just understand what you can from it. Write your best response so I know what you're thinking. Try not to make them too short. Give me maybe two or three sentences each of good information that you're thinking. So in your response, think about, why do we ask questions like this? About how old is the Earth? Why is evidence important? Like looking at the age of rocks or relative dating and things like that. Why is it important to explain what we see, right? So in a historical example, like when they thought the Earth was the center of the universe, right? They had to start looking at evidence that it wasn't. And they couldn't go out and show everybody that things were revolving around the sun. They had to use evidence based on the movement of the planets in the sky and things like that. So they had to be able to explain that with evidence, right? And so we have to use the best of what we have now. So discuss that a bit. Discuss how scientists work now and in the past. So some of the things like experimentation might be those dating methods and how those can be tested. And just kind of make this thoughtful. Again, if you don't understand every single detail, that's okay. But do your best to think about these bigger ideas of science this week and give me a nice response. If you would like, you can start practicing the Quizlet, but we will do that next week. So I just put their link there in case you wanted to get started. So yeah, quite a lot, but I was recording. Thanks for reminding me, James. So I'll post this at some point for you, at least by tomorrow, so you can watch it through this week. I'll actually try to post it today for you guys, but it might be after I'm done having class with grading. So yeah, anything else you guys want to ask or add before we go? So if you don't, then I suppose have a good day and message me if you got questions. Bye. You guys are free to go unless you got questions.